Now I'm going to talk about the loss of PIP alarm, which is by far the most common alarm that you'll see on the jet ventilator. Loss of PIP alarm is generated in one of three ways. Either there's a 25% drop from the set point of the peak inspiratory pressure, so the now PIP, or the peak inspiratory pressure is less than 3 centimeters of water, or the difference between PIP and PEEP, which is the delta pressure, is less than 2 centimeters of water. So 3 different ways that can happen. The loss of PIP alarm basically is caused by a variety of things, mostly having to do with either the patient affecting the pressures because of the level of activity, or moisture in the jet circuit, which either can come out of the jet circuit itself or out of the endotracheal tube. Those are by far the most common causes, and because of that, I'm going to take just a minute here as we discuss loss of PIP alarm to talk to you about proper control of the humidifier. When you first start the jet ventilator up, it automatically sets your control settings for the humidifier. It sets the default setting for the circuit at 40 degrees centigrade and the default setting for the cartridge at 38 degrees centigrade. In many situations, those set points are completely adequate to provide good humidification of the gas going to your patient and to minimize the amount of rain out that occurs in the jet circuit. Intensive care unit, where the air conditioning ducts are, where the doorways and hallways and traffic patterns are, the environmental conditions may be such that the default settings result in too much water being put into the gas flow and raining out in the jet ventilator circuit in this clear portion of the circuit between the front of the ventilator and the patient box. The goal in controlling humidification is to try to keep this segment of the circuit relatively dry, with just small patches of mist or fog in places, and making sure that the condensation in this part of the circuit between the patient box and the endotracheal tube adapter has a nice thick coating of mist or fog on it, so that you can quickly check to make sure that the patient is receiving adequate humidification. So let's say we've got too much water here in the jet circuit. We've got lots of droplets forming in here and little puddles of water at the bottom where the jet circuit is hanging down. What are the steps that we need to do to control that in a more appropriate way? The default setting of 40 degrees centigrade for the circuit temperature, which is controlling the gas temperature in the circuit being delivered to the patient, is a value that we generally do not manipulate. We know that there's a fairly significant temperature drop from the point at which the gas leaves the patient box and gets pushed through the jet adapter into the endotracheal tube. That drop is 3 degrees or more, so that if we're running the circuit temperature at less than 40 degrees centigrade, we're going to be delivering gas to that patient at less than 37 degrees centigrade, which is body temperature, and we don't generally want to do that with premature infants. So normally we do not manipulate the circuit temperature in trying to control humidity. What we do manipulate is the cartridge temperature. And if the default value of 38 degrees is too high, then what we want to do is lower that so that we're not putting quite as much water into the circuit, into the gas, and therefore minimizing the amount of rain out. So while the set point for cartridge is displayed, you want to lower the cartridge temperature, and the first time you want to lower it by 1 degree to 37 degrees centigrade. It will take approximately 20 to 30 minutes for the humidifier to readjust itself and to control that water bath so that it's actually at 37 degrees. In the meantime, you may want to try to remove the excess water that's in the circuit to help bring more stability to the peak inspiratory pressure while you're waiting for the humidifier to readjust. And you can do that, and you can do it while the ventilator is running on the patient, but you want to do it only if the ready light is lit on on the front of the ventilator, which means all of the ventilator alarms are active. And this relates directly to the loss of PIP alarm. What you're going to do is you want to manipulate the circuit in a way that allows you to move that water down toward the patient box. But you want to do that very carefully because there's gas flowing through the circuit. If there's a lot of water in here, the water can get picked up in the gas flow and pushed through the circuit into the baby's ET tube. And that would provide a lavage that probably isn't going to help your patient. So you want to be very careful in this process to make sure that there's not too much water in. If the circuit is really flooded, then you only want to do this in the standby mode. But otherwise, you can move that water down to where it's caught in a loop of circuit here just before the patient box. With the help of an assistant, or if you're ambidextrous, you can then disconnect the jet circuit from your patient's endotracheal tube adapter. And once it's disconnected, you can direct it toward a towel or a diaper, and then you can lift that last piece of circuit up, give it a little shake. The water will jet out of the end of the circuit. You'll see a loss of PIP alarm comes on. That's what you want. And then you can reconnect to your patient. As soon as you do, the loss of PIP alarm goes away. The servo pressure alarms and mean airway pressure alarms will also go away, and the audible alarm can be silenced by hitting the silence button. It's more efficient to get rid of the excess water in the circuit while the jet's running than it is while the jet's not running. So if there isn't too much water in the circuit, you can do what I've just demonstrated to remove that excess water, and you can do that safely as long as the ready light's on.